Hello everybody, welcome back. Today I'm going to continue the previous topic, that is types of machine learning, in which we were studying the supervised learning. Now I'm going to discuss types of supervised learning, in which we have two types: the classification and the regression. The classification is defined on labels, and regression is defined on non-label data. In this classification, again we have five algorithms which we will be discussing further, and in this regression we have only one classification further, that is linear regression. I'm going to cover this topic in this video, so be with me till the end of video. Now let's start with the classification. Here in this classification we are going to give a output which is a categorical variable. That means we are going to classify this output into a categories like the spam versus non-spam, emails, and yes versus no. This kind of outputs we are going to provide in this classification, which are defined on labels. Again, in this classification we have five algorithms, as I said before. The first one is the decision tree. In this, the decision tree is a simple diagram that shows different choices and their possible results, helping you make decisions easily. In this decision tree, but the name itself is saying that in this we are going to make decisions whether we are going to purchase the item or not. Like this, we are going to make decisions on based on the choices, the whatever choice which we have. This it is a graphical representation of different options for solving a problem and show how different factors are related. This is a graphical representation of the decision tree. Here the top is the root node, and the here the subnodes are the internal nodes, and at the last we know these are called the leaf nodes. It is same as the binary tree which we discussed in DSA, right? But it is not a binary tree, it is our decision tree. Here for example, if we want to purchase something but our budget is very less, right? If we get the items under our budget, then we are going to check the item, right? We will check the item and we will check the quality and all features. Then afterwards, if it is satisfying all the condition, then we are going to purchase that item, right? For example, now let's take the spam call example. Here we are getting a spam call from on our phone. Then we will decide whether to receive or not. On what basis we will get? On what basis we will receive that call? We will receive whether it is a spam call or not. Right? If we are getting a spam call, this decision tree is like this. If we are getting a spam call, and if we are not getting a non-spam call, then we have to make decisions whether we are going to receive or not. Like that in this non-spam also, either we are going to receive this call or not. If you are going to receive, then you will say yes. If you are not going to receive, if you will say no. Here also same, if you are going to receive, you will say yes, or else you will say no. If you are going to receive this call and you are saying yes, then you will talk, right? If you are not going to receive this call, then you will not talk. Here we have a spam call, right? If we are getting spam call, it is obvious that we are not going to receive it and we are not going to talk, right? If we are getting non-spam call, then we are going to receive it, right? Then we will say yes and we will talk. Or else if we are not getting that non-spam call, then we will not talk. This is how the decision tree works, or this is how the decision tree is. The real world example, like in shopping, if you are going to shopping, you'll go and check the budget of yourself, right? Then you will check if you are getting the product in that under that budget or not. If you are getting the product in that under your budget, then obviously you are going to purchase, otherwise you will not purchase. Like in real time example also, if you have to drink coffee, it which will be based on your mood and the time of the day. If you have a morning, then you will drink a coffee at the morning. And again, if you in the evening, if you are tired, then you will like to drink the coffee, or else there is no need of coffee. You say it is based on the your decision, right? You have to make the decision whether you are going to drink a coffee or not. Like this, that decision tree works. Now, moving forward, here we have second type of classification. Here we have second algorithm of classification, that is that is random forest. This random forest is a type of supervised learning algorithm that can be used in both classification as well as regression. This random forest is an ensemble learning method which combines a multiple decision trees to make a predictions, and it produces a more accurate and a stable prediction. Here, the random forest is a collection of decision trees that work together to make prediction. That's what I said. It is a collection of multiple decision trees which will give a accurate and a stable prediction. A random forest algorithm is a powerful tree learning technique in machine learning to make prediction, and then we do voting of all the decisions to make prediction. This random forest is a powerful tree learning technique in machine learning which will make predictions, and it will decide based on the votings or the majority of the what the majority of the decisions or the majority of the tree, what is the majority of the tree, it will check and it will make the prediction, and this prediction is accurate and is stable. For example, in a group of friends where for advice on where to go for vacation. Imagine your group wants to go for a vacation. You will ask each person where to go on the vacation, right? Then each friend will give their own recommendation that we should go there, we should go there. Then you will what you will make, you will decide two places. Then you will vote for those two places. If the group members are deciding to go on one place, that is majority of peoples are decided to go on one place, then you will take that majority, then you will decide that we will be going to that place. Like that in forestry also, it will take the decisions, that is multiple decision trees. Each friend is giving their own recommendation, that means each friend is giving their own decision tree on which that decision will be taken. That is, each friend is giving their own decision tree, that means it is collecting the different, that is multiple decision trees. Then what this random forest will do, it will take the majority of the decision trees, it will collect all the decision trees, and it will take the majority among that decision tree, and it will suggest that you have to go to this place. Like that, this rainforest works. Now here we have third algorithm of classification in supervised machine learning, that is support vector machine, that is SVM algorithm. This vector machine is a supervised machine learning algorithm used for classification and regression task. As random forest is used for both the classification and regression, this is also used for both classification and regression, but it is more suitable for classification. The main aim of this SVM is to find the optimal hyperplane in an n-dimensional space that separate data points into different classes. Here, the main aim of this SVM is to find the optimal hyperplane. What is this hyperplane? The hyperplane is the decision boundary which separates two classes in an n-dimensional space. Here, the main aim of this SVM is to find the optimal hyperplane. You will look what is hyperplane further, which separates the data points into different classes. The algorithm maximizes the margin between the closest points of different classes. I think you are not able to understand this. Let's take an example to understand. Here, hyperplane. This hyperplane is a decision boundary separating different classes in feature space, which is represented by the equation wx plus b is equal to 0 in linear classification. Basically, this hyperplane is a boundary which separates two classes. Now here I have example. Here we have an graph. Here this is known as our hyperplane, which is separating two classes here. Here we have two classes, that is, here we have positive class, here we have negative class, in which we have points. This is our hyperplane which is separating these two classes. This is what SEM is defining. Here it is the margin. How this margin is drawn? This margin is drawn by from the closest point to the hyperplane, the closest point to the hyperplane on both sides. These are known as our margin. This margin is the distance between the hyperplane at the closest point of the class. The key idea behind this SVM is to find the hyperplane by dividing or by separating two classes by maximizing the margin between them, margin between this hyperplane and the classes. This hyperplane is also called as hard margin, is the one that maximizes the distance between the hyperplane and the nearest point to the both classes. Here we have this as a we have this as our nearest point to the hyperplane, right? So the margin is drawn from this nearest point. This is our hyperplane. Now we have our fourth algorithm of classification in supervised learning, that is naive Bayes classifiers. This is used for classification task which is based on the Bayes theorem to find probabilities. This naive Bayes theorem is basically used for classification task which is based on the Bayes theorem. Let's see what this Bayes theorem further. It is used for finding the probabilities. As you know, what is mean by probabilities, right? The main idea behind the naive Bayes classifier is to use Bayes theorem to classify data based on the probabilities of different classes given the feature of the data. It is used mostly in high dimensional text classification. As we know what is mean by probabilities. This naive Bayes theorem is a classifier which is based on the Bayes theorem. Here we have our Bayes theorem. The Bayes theorem, it finds the probability of an event occurring given the probability of another event that has already occurred. It gives the probability of an event occurring, which give the probability of another event which has already occurred. This is what the Bayes theorem is. Basically, this naive theorem is based on Bayes theorem, which find the probability of another event which has already occurred. That means here we are going to find the probability of an event occurring, which gives the probability of another event which have occurred already. So this is the basic of what the naive theorem classifiers are. Naive Bayes algorithm is used in spam filtration, sentimental analysis, and classifying articles and many other things also. This naive Bayes classifier is a simple probabilistic classifier and it has very few number of parameters which are used to build the ML, that is machine learning models that can predict at a faster speed than any other classification algorithm. So you can say that this is a very optimal or a very faster algorithm than any other algorithm, because it finds it consider only few number of parameters, so which are used for building the machine learning. So it will use few parameter as well as it will predict the output in a very fast speed. Now we have our fifth and the last algorithm of the classification in supervised learning, that is artificial neural network. As you know how our brain works, right? It consists of a neurons or a nerve cell that are our primary units of our brain, right? Using these nerves only we will receive the sensory input from the output world, and it will process and it will provide the output to our input, right? Like that only in this artificial neuron also, as the neuron's name is appearing here, you'll get an idea what we are talking about, right? In this artificial neural network also, it has a artificial neurons called units. These units are arranged in a series of layers that together constitute the whole artificial neural network in a system. As a human brain has many millions of neurons which are connected to each other, right? And these neurons only constitute of a human brain. Like that, in artificial neural network also, the units are arranged in a series of layers. These units are connected with each other, and it has formed a series of layers which together constitute the whole artificial neural network. This is the same as our human brain. A layer can have only a dozen units or a millions of units, as this depends on how the complex neural network will be required to learn the hidden patterns in the data sets. This artificial neural network can have few units or millions of units, right? As human brain have millions of neurons. Like that, in this artificial, we can have only few dozens of units or millions of units. If human beings have only few neurons, then the human being is not stable. It should have millions of neurons. But in the case of artificial neural network, we can have only few dozen or millions of units. This depends on how complex the neural network is required to solve the problem or to learn the hidden pattern in the data set. This units is depend on the type of the problem you are solving, or the type of the pattern you are learning. On that pattern, on that basis, on that basis, the layer is formed using these units. Commonly, it has an input layer, an output layer, as well as the hidden layer. The input layer receives data from the outside world, which the neural network needs to analyze and learn about. Like in human beings, the input is provided by the outside world. Like if we want to check what we are touching, right? If we are touching some kind of ball or pen without seeing it, then we have to analyze it, right? First of all, you have to analyze what shape it has, right? If we touch, we'll not directly come to know what it is. Then this touch is a one type of sense, right? Then this kind of touch signal is provided to our brain, which has several neurons. These neurons will analyze the signal. Then it will give the after analyzing, it will give the another signal to our response. It was as a response that it will say that it is a pen that which you are touching. Like that, in this artificial neural network also, the input layer receive data from the outside world, which the neural network need to analyze and learn about. After touching something, it will analyze and it will learn. Then the data passes through one or multiple hidden layers that transform the input data that is valuable for the output layer. Li- Like in human beings have millions of neurons, in this artificial neural system also it has a multiple hidden layers. The data passes through these multiple hidden layers, and then it transforms the input data into a valuable output. Finally, the output layer provides an output in the form of a response of the artificial neural network to input that provided. As I said, right, in the case of human beings, like that, only in artificial neural system the this neural system works. So this is the representation of neural network here. Here we have input layer, here we have output layer, and in between we have a hidden layers. There are millions of hidden layer. This is a overview of artificial network layer. This artificial neural network is a very complicated concept. Here I have provided a very brief information about it, but it is a very complicated and very technical concept to understand. So these are our 5 algorithms which are in classification of the supervised learning. Let's move towards the regression. Now let's move towards the regression. Now we have the second type of supervised learning, that is regression. This regression is also one of the type of supervised learning technique where the goal is to predict a continuous variable value which are based on one or more independent features. Here we have two types of variables, the dependent variables and the independent variable. The dependent variables are the variables on which we are going to make prediction. That means the targeted variables. And the independent variables are the input variables on which the prediction influence. For example, if we are going to purchase a car, then this car is our dependent variable. And the features of the cars on which we are going to make prediction and which influence the prediction are the our independent variables. This regression finds the relationship between the variables so that the prediction can be made. That means here we are going to define the relationship between the independent and the dependent variables. This regression can be classified into many types, but most widely used classification or the type of regression is Linear regression. This linear regression is a statistical method used to model the relationship between a dependent variable and one or more independent variables. We know that the regression defines the relationship between the dependent variable and the independent variable. This linear regression is also one of the classification or the type of regression in which it it gives a statistical it in which it uses a statistical method to model the relationship between the dependent variable and one or more independent variable. As we know what are dependent variable and independent variable, this linear regression also does the same. It finds a relationship between the dependent and independent variables. It is a type of supervised machine learning algorithm that learns from the labeled dataset and maps the data points with most optimized linear function, which can be used for prediction on new data sets. As a supervised learning itself works on the labeled data, so this linear regression also uses the labeled data set and it maps the data points with most optimized linear function, which means the most optimized means the most valuable or the most minimal values or the functions which can be used for the prediction. So these are used for the prediction on the new data set which we provide. It computes the linear relationship between the dependent variable and one or more independent features by fitting a linear equation with observed data. For example, when we are given a features of the car, then we have to make prediction using those features which fits our requirements. So here it is saying that we have to fit a linear equation. That means it should fit our requirements. It predicts the continuous output variable based on the independent variable. Here is an example. Real estate data is collected which includes the information about the houses such as square footage, number of bedrooms, number of bathrooms, location, age, lot size, etc. These all are our input variables on which we are going to predict the house prices. Linear regression uses all these parameters to predict house price as it consider a linear equation between all these features and price of the house. So this is how linear regression work. It makes the predictions on the input variables that those are our independent variables like these features. On this feature only the independent variable which is our house on which we are going to make prediction. So this is how linear regression works. This is all about the supervised learning and its types. Thank you for watching my video.